Most people envision AI as a cool and orderly data center activity, but this technology will soon be everywhere. This episode of the On Premise IT podcast contrasts the AI based greenhouse of Nature Fresh Farms, as presented by guest Keith Bradley at AI Field Day recently, with those massive GPU bound infrastructures that many people imagine. Join Allison Klein, Frederick Van Haren, and myself as we talk about AI in the real world. Welcome to the On-Premise IT podcast, the only show that dares to be both on topic or on premise, and sometimes even on location or on premises. Each time we meet, we bring together a group of IT experts to discuss a single idea. Today's episode was inspired by our recent AI Field Day event, where our special guest talked about the real world of implementing AI applications, which, spoiler alert, ain't at all like what you think it is. So before we dive into that conversation, let's meet who's on the panel today.
I'm Frederick Van Haren, the founder of Highfence, which is a consulting and services company active in HPC and AI.
I'm Allison Klein. I'm the principal of the Tech Arena. We cover everything from the data center to the edge.
Hi, I'm Keith Bradley. I'm the Vice President of Nature Fresh Farms, and I do everything that's involved in our on-structure and on-demand infrastructure that runs our greenhouse.
And I'm Stephen Foskett, organizer of the Tech Field Day events, including the AI Field Day event that we just held. Now, all of us were at AI Field Day, and I think that all of us will probably already knew this ahead of time, but many of our listeners may be surprised to learn. If you ask people what does an AI infrastructure look like, I think they've got this vision that it involves, I don't know, like a huge data center, like from something like a Hollywood movie with all these, GPUs. Every one of them costs as much as a Honda Civic. And you've got, all these blinky lights and all this stuff, and it's cold and it's clean. But that's not really the reality of AI. In fact, that hasn't been the reality of AI, and it won't be the reality of AI. As we discussed at Field Day with Intel, AI is going to be in lots of locations. It's going to be built into stuff. It's not all going to be GPU based and everything. I think people would be really surprised, though, to hear, Keith, a little bit about your real world AI. What does your AI environment look like?
So in some ways, it's a very simple AI structure that we started off based on VxRail from Dell and an Intel processor. We started off with 3 simple nodes to start our AI journey. Then we expanded to 5. Then we even expanded to 7 with a dedicated one. And that's all we've really used so far. We've added GPUs, but we haven't actually turned them on yet because we haven't seen the benefit yet that we need to do the next step.
In terms of your environment, though, the infrastructure, literally, I'm trying to get you to the greenness
You want to see
of
the
it.
greenness of what we do. So
Yeah.
what we are is we're 250 acres of greenhouse, all enclosed, all working to do and control the life cycle of the plant. Like I actually mentioned at Tech Field AI Field Day, is we're like, think of us as like a hospital. We control every aspect of that plant's life, just like a patient does. And we need to function 24/7 to do it. There is no natural light that really comes in. We filter it. We just choose how much it gets. No artificial rain coming down on the plants. We do everything like that. And that's spread over 250 acres, about 7 or 8 different locations, depending how you look at some of our different facilities. And we control that all basically from one core infrastructure. One core device runs every area with a lot of edge compute happening in different sections.
So how did you go from tomatoes and peppers to AI? What was kind of the incentive for you to look at AI?
It was actually a natural evolution for us. We always were data driven. We were always looking at our history. How do we make things better? How do we learn from our past? And that's basically kind of the premise of how AI does. It takes the data and tries to make a better decision. But one of the biggest things that really pushed us in a way was how do we change our greenhouse from being reactive? Oh, the sun has changed, this has changed, and the plant suffering for a few minutes because we weren't quick enough to do it. A human being can't make that change fast enough. He can't react to every element out there. So we started to look at how do we use machine learning and to a degree AI to make our greenhouse predictive. So it is going to be proactive and predictive of what it needs to be during the day, at night, in the morning. Oh, a storm is coming through. I got to shut my vents off. I got to close things up because the humidity is going to get too high before it happens.
I'm really curious. You've been running the infrastructure for this company. How did you start ramping on machine learning and actually move into the space of thinking about applying artificial intelligence to the challenges you were solving for the plants?
So there's a lot of little projects that started it. You know, if you look at one of the projects that we did do, and one of the things that you don't realize in a greenhouse too is we have a very large biological team, and they look for bugs in the plants and how to get rid of them. And it's hard to train people to look for the bugs. We spent a lot of time training them, so that was one of the very first things that we really pushed. We can just truly make an AI engine to do this. So we started teaching the machines what happens. But it was also one of our biggest failures in AI too, because nobody can find a bug. It's like trying to find that spider that you lost in the kitchen. You know it's there, but you don't know where it is. And so we had to take the machine and not look for the bug, but look at the data behind it. Did the leaf wilt? Did it stop taking as much nutrients? And those are the type of things, Allison, I think that you're looking for, that we had to learn and let the AI learn. So we even went as far as investing a plant with something and letting it learn how it reacted.
It's really cool to think about the kind of sensors that you're talking about because these aren't exotic things, right? I mean, you've got what probably moisture sensors, cameras, maybe IR cameras. None of it is, really crazy exotic. It's all pretty normal stuff, but it's the AI is making the difference by processing that data.
Yeah, it processes the data and allows things to be seen that a human eye can't catch if you haven't been doing it for 10 years. Because the AI just learns. And it was such a great revelation for us to see how an AI just, once you get to the point of it actually learning properly and you kind of get that tamed down, that you don't need that expertise anymore out in the field. You can more let them go do other things now and start the next step of what you want to do. And the basic inferencing is what they do.
So you talk a lot about ingesting data, but you're running a 24/7 operation, right? So as far as streaming is concerned and the amount of sensors, you must have a massive amount of data. How do you handle data management in general? I mean, you can't keep data forever, right? I mean, unless you have really, really deep pockets. How do you handle deep data management in general in your operation?
A lot of the things we do is very transactional. So we don't store a lot. It's just coming in and out. It's not storing it, it's just flowing in. And we're only looking for inference changes to the information. Um, Example, temperature changes. Like the temperature usually is pretty steady in the greenhouse. So we don't really monitor that, but it only monitors when there's a change. So we're able to get rid of that. Pictures go in and out very quickly. We don't keep pictures too long. We basically make the decision on it and then move on. And it basically goes into an analytics of what it was seen. So it's not an image anymore taking up a lot of space. It's more just a few key data sets of what was looking for within the picture. And then that allows us to compress that data. We go through massive amounts of data, and that it is true that we have a hard time. We have do have a very large data set of stuff. I'd like to say bigger than you. We hold on average about 250 to 300 terabytes of data on premise at any one point in time. And depending on the time of year, it goes even higher than that.
So when you think about what you've described, measuring the plants, measuring changes in the plants, tying those changes to root causes, what has been the impact on your yields or the health of your plants? What are the things that you're measuring in terms of the efficacy of applying AI to how you're managing your crops?
Yep. So one of the things that historically used to happen, and it was just, we always considered it just a natural part of the life cycle of a plant, is a plant would, and I guess to say we call them a flush. So every so many weeks, a plant would actually have a very big burst of energy and it would do a whole bunch of peppers or a whole bunch of tomatoes all at the same time. When we introduced AI and it started to work, it started to eliminate the amount of flushes and more just made it a straight line across the entire life cycle of that plant. So what that was able to do now is we're now able to more accurately say to our suppliers and the grocery stores, this is how much we're going to be able to get you each week. So it led to a lot of less waste. And then now we've been able to record it back to a nice per meter squared. We're always looking to increase the yield by 3% per meter squared, we call it. So that way each year we try to get more out of the same space using the same resources, which again is great for everybody because we're not needing more space to make more product.
I think it's interesting because most people, well, they might not have thought about these applications, but these are really, really powerful applications. And what you're talking about are sort of, uh, well, honestly, this is kind of table stakes for every kind of business, whether it's a manufacturing business, food service, industrial, agriculture. They want to increase yields, um, and yet, you know, I don't think they. I think a lot of people might be worried about how to start. How did you get this stuff together? How did you get started with this? What components did you use? You talked a little bit about the infrastructure in terms of server hardware, but what about software? How did you do this?
So it was a lot of AI tech stuff, I can say. OpenVINO is our core AI inferencing, CODA, things like that is where we all started. But I like to always say that, you know what, I like to believe there's no starting spot. You can just say, this is where you start and this is how you start your AI journey. For us, we learn more by failures than ever succeeding. We learned more by just going out there and saying, we're going to do this. We're going to try this, and it's going to be great or terrible, and we don't know, and doing it. But really, we just started off with a bunch of university students, me, and a couple growers saying, how do we jump into this? And how do we embrace the technology and not say that it's too hard? And, we just kept plucking at it. Like to say a lot of nights with pizza and pop sitting there or pizza and soda, figuring out how do we do this at night and just playing with the engines and the machine learning language. Okay, let's change this, let's change that. What results do we get? But that's really just how it started. I guess every time we do a different project, it all seems to start different. And sometimes I look like we've learned a lot, but we still kind of start off the same way of just how do you invent it.
Right. I think that's the right way to do AI, right? It's, you throw stuff at the wall and see what sticks. What are kind of the main challenges you see today that you would like to see resolved?
Uh, Enough people to do the projects is the first one. There's never enough people out there that really are good at it to do, especially, we're remote locations, stuff like that. We're a company that still works very much in the office. So it's hard to get the people to come in to do it. And for me as a greenhouse, I'll admit to you, it's hard to talk anybody of any senior level of technology to say, hey, come join a greenhouse. We're going to have fun doing AI. And they look at me like, this is not going to happen. But the biggest thing from the AI perspective, I think, is, getting that more stability and more of a general understanding of a platform of that first step. I don't think we need the second, third, and fourth step, but just that first step. How do you build that foundation to start your AI that's not going to cause you to break down when you get to the fifth step? Because, for us, it was a journey. It was something that we didn't know. And I think I like to say we luckily did it right and for what we needed, but we had no blueprint to follow that first step. How do you build a foundation for AI?
I'm still thinking about what you said about bugs. And it made me laugh because I thought you were talking about software bugs at first because that's the world that I live in, but you're actually talking about real bugs. Um, One question that I have for you, you've described a lot of areas where you've had great success. As you started studying things and started applying technology, were there any areas where you realized actually this wasn't going to yield anything that was going to be productive, and any funny stories along the way?
It is funny because you think that, every robot you see out there does manual labor and stuff like that. To this day, we've still struggled to find a robot that can pick a pepper, pick things like that faster than what a human can do and more accurately. And we have tried and we have failed. And I think it's going to be another 5 years before they actually get mechanics to that point, because it's not an easy environment to work in. It's very tight. You need a lot of equipment to do things and to do it. We've had a couple of small successes with the very small cherry tomatoes that everybody likes. When you get to the bigger stuff, it's just so slow to do it. And so I'll admit we've spent a lot of time trying to make it and never gotten there yet.
It's really wild for me to think about that we've got a situation where you've got like literal dirt and bugs, and you've got plants, and then you've got humans, and then you've got frickin' servers and sensors and
Yeah.
AI, and that's all part of the same recipe. I mean, it's just such a cool thing, and I think it really does open the eyes and make you realize, as I said at the beginning, that AI isn't something arcane that happens in the cloud and in the data center, and it's not billion parameter models that are like, putting writers out of business or whatever. It's practical
Yeah.
applications.
And it's funny because most people always think, and most end users I find, they find AI is just chat GPT and text and stuff like that and things like that. They're not really getting the bigger things that AI can do for us. But it is funny how even my team relies on that type of AI to start their programming though. Because they've learned we start to do it just from there and then we edit the code. But you look at what we do, it is so different and it is so exciting in some days to see, an actual robot go down a 500-meter row of peppers and learn something and come out of it and show you this is what I learned.
Yeah, and I think there's also a big challenge as far as real time is concerned, right? If the weather changes, you can't wait 2 hours, right? You kind of have to react almost immediately. So I presume that on top of the AI and building the models, there's also a need for a significant amount of automation such that actions can be independently reacted upon in the field.
Yeah, our entire greenhouse is automated. Like everything from irrigation to lights to vents to heating, cooling, everything top to bottom, we can all do from, I can basically do everything sitting on a computer anywhere in the world and adjust the climate of my greenhouse. Or, as I like to say now, tell the AI what I want my greenhouse to be. And it basically follows that recipe for them and it allows them to stop worrying about how do I make those minor adjustments you're talking about there, Frederick, each day, as the weather comes in, to more be out again with the plants and look at what they're actually doing.
You know, I'm thinking about this, and I think it's a wonderful use case because while we're, just talking about the peppers and the tomatoes, obviously what you're doing will have a great footprint on a larger challenge that we're facing as a planet in terms of increasing crop yields and feeding more and more humans that exist here. What has the conversation been with others in your industry? And are you seeing growing trends across agriculture to apply AI?
It's been a big trend. Everywhere we go, every agricultural event now, AI is starting to be a topic of conversation. Everybody's at a different stage in their journey. A lot of them are just starting to how do we get into it now. But like you said, it's everybody knows this is how they're going to make themselves better. This is how we're truly going to see larger increases and more steady production in the long term. So it's really getting adopted by every greenhouse. It's something that even the major vendors are all adopting now.
So a few weeks ago, the farmers in Europe were on strike, and they were talking about the cost of producing the tomatoes and the peppers and the potatoes. And so the question I have for you is does AI help you financially? I mean, deploying an AI infrastructure is not cheap, right? And considering everything, does that help you economically as well?
I always like to put it in perspective. I have a very healthy budget, but my budget is nothing compared to what the growers' budgets are in the real world, like what they are, the amount of fertilizer, energy it takes to do it. So if $1,000, or $100,000 worth of server can help a $600 million crop help out, it really is a small percentage. So that's why, like, that little investment, it feels like a lot because we're farmers. Let's face it, we're farmers. Why do we need a computer? And even some senior managers still, why do we need it? They're just starting to get to that point that that's what we need out there, and it will help them. But yeah, our costs are rising exponentially every time we do things because the cost of gas is going up, the cost of fertilizer, everything is going up. So that's why we need to get more optimized.
Well, from that perspective, I mean, we are a nerd podcast
Yeah.
here. We typically have a lot of techies listening. Can you talk a little bit about the infrastructure that you're using? So again, most people assume GPUs. We know from your discussion at AI Field Day that you were able to do some of the inferencing on the CPU with the Intel Xeons. Talk a little bit maybe about how that's working.
Yep. So, it was funny because we started off, like I said, we started off with like a 3-node cluster, single CPU, just a plain Jane. Let's just start to figure this out in this world. Then we needed a little more power, so we went to 5. And now in the last 3 or 4 months, we actually finally really said we're going to get a CPU driven one that has a very high end Intel Xeon processor. And we also did add the GPUs to it, but we haven't even turned those on yet. But we already seen some of our machine language models and our ETLs, we like to call them, run that used to take 3 to 4 hours run are now running every 30 minutes. So we've seen a big savings on that, in that it was able to make that decision now every 30 minutes instead of only a couple times during the day. So we've seen a big benefit just by going to a higher end CPU, let alone having to add these GPUs that you said cost you a Volkswagen and a half sometimes just to add. But we've gotten there without these. So now it really raises the question, do I really need to jump to that next level of adding them?
And what does your decision process look like around that? So, I mean, I imagine that there's a budget component to it, and there's probably also an availability component to it where you're saying, and probably power and cooling and space and all sorts of things that are a lot more practical than people might think.
So that's the thing, licensing is not cheap for GPUs. It was something I didn't really, I'll be true, that just shocked me when I found out, oh, I got to license a GPU. And I'm like, well, what do you mean? It's a CPU, it's just a different type, but why do I need a license for that? And so it kind of threw us off. So we had to actually get more budgeting for it. And we're still kind of fighting through that concept of getting that budget for this. But now the budget to do it is so much, it's like, do we really need it? Like, how much, we went from 30 down to 30 minutes. How much more do we really need? And can we solve that just by adding more CPUs through just a regular CPU platform than having to go to this GPU route? And one of the things we found with the GPUs is they're not 24/7 liking, where they don't like to move within our VxRail environment. They get very locked down to a single node. So if that node failed, that AI could possibly crash. Where when it runs off the CPUs, that one node crashes, we're just going to keep going because everything's going to move over to the other nodes. So it's a lot of things for us to think about and figure out yet.
Keith, I think what you just said is so important, and it reflects on something that I come from the semiconductor industry. I think that the semiconductor industry always thinks that people want the Maserati. They want something that is the fastest, and if it's not quite as fast, if it's just a BMW and not the Maserati, it may not be good enough. We're just going to use car analogies throughout this podcast, everyone. Um, I think that what you just said is so important, which is this could be fast enough for us. We really don't need more performance. And this is infrastructure and a software stack that we're comfortable with. So we're going to go with this. And I think that when we look at the broad proliferation of AI across so many different use cases, across so many different industries, I think that there's going to be a lot of examples that are similar to yours, which are, I don't need the Maserati. I'm not training OpenAI for 6 months within a 250-acre data center environment, similar to your fields. Um, I'm just doing, a specific workload that really is important and critical for my business. I think that's the big takeaway here.
And as the CPU generations get better and better and better, we're seeing the performance increases. Like that's where it is. And I'd like to say we got lucky. We built on a platform that we can just add more nodes to increase that compute. So it's not like we have to add more and then move things around. We just literally plug in another node, assign it more CPUs, and there you go. So we got lucky in how we built it that we were able to do that, because I look at where we went from 4 years ago when we first got our first 3 nodes to the compute power of our latest 2 nodes. It's night and day difference. But now we can just keep expanding that. But it's a semiconductor world where they keep increasing the yield every year, just like we do.
And they keep implementing new capabilities on the CPUs
Yeah.
as well. I mean, you've got accelerator instructions already in all the major CPUs, and now we're starting to see special purpose NPUs built into the CPU stack as
Yeah.
well. And of course, yes, there's a place for accelerators and GPUs as well. But one question specifically, technically, you didn't train your own model, right? You're just using you're using pre-trained models with transfer learning.
Yeah. Pre-trained models. So we're playing with learning our own and doing that, but we do a lot of pre-trained models that start off as a core set, and then we go from there and modify it.
So where do you get your pre-trained models? I mean, is there a community where you kind of share and improve the pre-trained models as you go?
Yeah, there's a couple of pre-trained ones that are out there that we do kind of start it from, but everything is about the same. It's just it usually starts, most of our models start off, this is a healthy plant. And then we have to teach it this is an unhealthy plant and what to do with it. So most of them are on that. There's no real formal community. I'd like to say that Greenhouse is pretty tight in some ways, but we do share a few core things like this with each other to help out.
Do you have any ideas about what you want to tackle next?
The biggest thing that we're looking at next, and I'm not sure if I already said it, is we're starting to learn how do we make a perfect bell pepper. So right now we have 100,000 bumblebees pollinating our flowers, but they pollinate at the moment they get to it. So we're looking at is there a time that you pollinate a flower to make a better pepper, to make it more perfect? So we're still learning that process now of, okay, we're going to pollinate it at this stage. Maybe this plant has three flowers on it, but we're only going to pollinate two of them, where the bee will pollinate all three. So that's where the next thing we're going to help increase our yield is by how do we dictate how many fruit and how much load will be on that plant. Because it's not uncommon for us to go through and say, you know what, just pick a flower or pick a prune off it. Just like, in movies, they do apple picking. They always say pick two and you get rid of the next, you bite off the flower for next year's yield. We do a lot of stuff like that. How do we control that yield to make it grow? And then how do we react when maybe the plant's not doing as well and it doesn't need more plants to grow? So there's a lot of variables in that.
Do you expect to have AI making those decisions?
I would expect so. Yep. I'd expect in the next couple of years we'll have AI dictating the planting cycle of it. Like I said, it's almost a full circle, because before bumblebees, the growers used to go around with pollen and pollinate every flower. Then they had the bumblebees doing it. Now we're almost going back. This time it'll just be an AI robot out there giving a puff of pollen to every flower.
Well, that's an interesting perspective. It's an interesting vision, I think, and maybe again not one that people would think. And to me, that's the takeaway from this. AI. I think that if you ask people what AI looks like, they don't envision a greenhouse. They don't envision a perfect tomato. They envision, cold, hard, maybe evil computers stomping on us and taking over. But no, it's feeding us, and that's incredible. So thank you so much, Keith, for presenting at AI Field Day. The great conversation you had with Keith Townsend there is just well worth listening to. I want everybody to just go over to your favorite search engine, look up Keith Bradley, AI Field Day, you'll find it. Also, check out some of the other presentations there. We posted them all on the Tech Field Day YouTube channel. Before we go, where can we continue this conversation with you? Frederick, Allison, Keith, let's go ahead.
Yeah, so you can find me on LinkedIn as Frederick V. Heron, or on my website, which is hifence.com, which is HIGHENFS.com.
And I'm Allison Klein. You can find me on LinkedIn. You can find me on Twitter at TechAllison. You can also find me on my website, thetecharena.net.
Hi, and I'm Keith Bradley. You can find me on LinkedIn. I'm not really out in the social media as much as everybody else, but that's where I do most of my stuff. I'm a simple guy.
Excellent. And do check out the presentations from AI Field Day. Thank you so much for listening. If you enjoyed this discussion, please do subscribe. You'll find us in all your favorite podcast applications. Please give us a rating and a review as well. We'd love to hear some feedback from you. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise, now part of the Futurum Group. For show notes and more episodes, go to GestaltIT.com/podcast. Thanks for listening, and we will see you next week.